Hello my friends, welcome again to my video channel. Today we will continue our work on the Kenwood TS950S and we have to examine the problem with the RXB line. So let's start. To get access to the control unit, it's necessary to remove the front panel. That's rather easy. There's a screw. This hole is in line with this hole. One screw has to be removed and the other screw only has to be unscrewed half a turn or so. So we can slide out now the front panel and move it down carefully. Of course it's necessary to support the frame, the chassis, with a piece of wood or similar, so that the knobs and pots on the front, that these knobs are not damaged, and even there are some contacts behind here, some plug contacts, that they are not moved or broken or so. And then we can have a look inside. What a machine. What a machine. The control board is this board. It's only the fan which switches on and off. This one where we have this ribbon cable, it's another control unit. Don't know what this is, processor. Okay, but what we are looking for is this control unit, and the TRX module, maybe you can see it, is this one here. I make a better picture so we can see the module. But in the moment the receiver is working. We have no problems. It's a dentist effect. We can see we have good reception. And when I switch on the internal marker, there's a marker inside. Main receiver and sub receiver. I have mode USB, but the wrong mode for this band, but doesn't matter. Both receivers are working. But there must be a problem. There's a problem. One of the first tests is a simple mechanical test. The 15 volt in feed is one of these red wires which comes in from the power supply, which is here in the left corner, where we have measured the 15 volt, which is okay. It comes in. When I use a plastic tweezer, nothing, no problem, can be identified. The TRX module, when I grasp it with a tweezer and move it, nothing. Here we have the output. This ribbon cable goes to the signal board where we had a problem in the AGC line. When I touch it and move it, nothing. All is okay. For a second I had a problem with the interruption of the receiver, but in the moment when I tune it to the signal, to the calibrator, nothing. Everything seems to be okay now. This is cruel. Maybe I have to retighten the screws, but I think it's not a ground problem. And the other pins are not relevant, the other connectors, because 15 volt is coming in, it's fed to the TRX module, and then it's fed to this CN20 to the output, which goes to the signal board. And here we have the problem. We have it identified on the other side, on the signal board. But in the moment, no problem. Just to check it and to show it, I'm measuring at pin, what is it? I think it's pin 10. pin 10, that's the RXB signal here on the TRX board. And when I go connect my probe there, and we have 15 volt. That's the RXB voltage, the switched voltage, which should be 15 volt, and it is 15 volt. So in the moment the receiver is working, I have to wait until we have the problem, and then I can measure this voltage again, the output of this TRX module, whether we have the problem there or anywhere else. Another possibly mechanical problem could be the output of the voltage regulator. It's a connector CN5 which supplies a 15 volt to the control board. The connector is this one, difficult to see, but the red wires are these one, but no effect. Reception is okay. I'm gonna touch this, move this, nothing happens. Where is the problem now? I brought the front panel back into its original position. We have reception of the calibrator. When I switch it off, we have no signal. Switch it on. Now it works. What have I to do now? Well, is it a contact problem and I solved it by moving around some connectors? Could be. I'm not convinced. Is it a problem with a semiconductor? I have to wait. For this day I will close the station here and continue my work tomorrow. Up to now I had no chance to reproduce a fault by mechanical influence, so I use the next step of escalation, which is heat and cold. I first apply some cold spray or ice spray and apply it to the TRX module. The calibrator, you can hear it, is received, and now I apply the cold. Nothing. Nothing happens. Still reception. The output of TRXB is still 14.98 volt. So I would say the problem is not on this module. A little bit. Haha! And while I'm talking nonsense, 13 volt. And now I go to the input. And input 7 has still 15 volt. That's pin 7 on the TRX module, which is the input, and output is pin 10. Okay. Now it totally dropped down. 4 volt, 5 volt. As shown the schematic. Pin 7 is plus 15 volt, still present, but the output pin 10 is not present. As we have seen, so the switching on the TRX module is obviously the problem. I have to take out this module. I check the output of the TRX module and I see that the output voltage is increasing step by step, slowly. In the moment not. This is an indication that we have a problem, not with a contact, I think with a semiconductor. This slowly increases with decreasing temperature, or increasing temperature, so the temperature increases, of course. Now we have reception again. This could mean that the switching transistor on the TRX module is faulty, or maybe one of the resistors which control this transistor. Anyhow, I have to take out the TRX module. The control board is unscrewed, only 4 screws in the corner. 2 plugs and 2 ribbon cables have to be removed and it can be flipped out. And then we have access to the bottom side, and the TRX module, which is behind this bigger one, can be unsoldered using a desoldering gun or similar. Best is a desoldering gun, I think, because solder wick or solder braid is not so good in this application. We have a double-sided PCB with vias, and vias can only be easily unsoldered with a desoldering gun. Whenever you do such a work, cover or protect the lower boards with a towel, skirt or similar to prevent any solder beads to drop into the circuit, which would be ugly. The TRX module is out, and there happened what always happens: one of the vias came out. They shouldn't come out, of course, but they came out. It cannot be avoided always. The quality of the PCBs is not the best, and even with a desoldering gun it's difficult. But in this case it's not critical because this pin is not used. Here I lost another pin. It was unsoldered here on the board and not in the via, so it stuck in the board. But this pin is also not used. If this happens to a pin which is used, it has to be resoldered on the board. Look for the vias, whether the trace is on the top or on the bottom side. Sometimes traces are on top and bottom side, so the via is necessary. Be careful when reinstalling it, but in the moment it's not a problem. As I see, I will remove all pins which I don't need. I don't resolder them. It's easier in the future to take it out. The board is not damaged. It looks rather good, except for this via, which came out, of course. But in general, it's okay. And now we can focus on this TRX board module. The TRX module is on an experimental board now. This brown wire is a connection to the ground connections. It's pin 1 and pin 11. The power supply is fed via these 2 pins. It's pin 7, which is plus 15 volt, and this other yellow one is the ground. And here we have the output. Pin 2 is the RXB output, where we have the problem. And this is also ground. I measure the voltage of the output. Additionally, I will load the output a little bit with some 100 milliamps, because the switching transistor should see a load, not only the high impedance of a voltmeter. I've chosen 39 ohms at 15 volt. It's approximately 400 milliamps. I'll be connected in parallel to the output, which is here. This one and this one. Bend it away. The voltage dropped a little bit. The power supply shows for something in the range of 400 milliamps. That's okay. And now I will treat this module again with cold spray. And we see nothing happens. Nothing. Output voltage is stable. We still have 400 milliamps flowing. There should have happened something. When I remember in the TS950 it took about 15 seconds or so until the voltage dropped, but now it is stable. And the transistor gets warm again. This is not nice. And we see voltage is coming back. We had a short dip. Okay. By the way, you may ask what is the maximum load for this transistor according to the data sheet. Well, I've checked the data sheet. Continuous current is 800 milliamps and the safe operating area is up to 2 amps. I assume with some cooling, but it is only switched on and off. So we have no problems with a current of 400 milliamps. This is within the specification. And the transistor can drive this because the base resistor, we can see, is only 470 ohms, which is connected to ground. That means the when we have here the positive, the plus, it's a PMP. So the base current is in the range of 15 volt dot 5. That means 30 or 40 milliamps. Is it true? Yes, 15 volt divided by 0.5 kilo ohm. It's 30 milliamps, and the current gain is in the range of 70 or more. So we can generate here without any problem a current of 2 amp flowing out into the RXB line. So we are in the specified range of this transistor with this setup. I use the heat gun. Same result. The output voltage drops. We can see 12 volt. Another interesting measurement at the emitter of the transistor, we still have 15 volt. The base has still, or has 14.3. Okay, a little bit high maybe, but the output is 14.8 now. Well, I have to heat it up again. Now we have an output of 8 volts. The emitter voltage is still 15 volts. The base voltage is 14.5, 14.6. And the output still is only 3 or 2 volt. .15 volt, 14.4. So the base emitter voltage of the output transistor seems to be okay, only the output is not okay. So I think another problem with the contacts. So I'm quite sure that the problem is indeed the output transistor. The transistor doesn't like heat, doesn't like cold, so it has to go. And now it's time to swap this transistor. We have seen that this transistor is obviously the bad guy. It's temperature sensitive on the board. It is this one, Q151. Here we have the board fixed in a vise. And this transistor has to be replaced by a new one. I got a new one. Checked it, it's really a transistor and not a fake or so. Nowadays we have to be careful when buying semiconductors on the market. Sometimes even simple transistors are faked, but obviously this is a good one. I measured the beta with 175 or so, that's within the data sheet, so I can replace it. The new transistor is soldered in. It's necessary to have a good connection for the collector for better heatsink, and now we can check it. We have the same test setup as before. Supply voltage is 15 volt. Now we measure the output voltage over the load resistor. It's 14.84. That's okay. I will use the same procedure with some heat and some cold to check whether we are on the safe side now. And as it looks, no problem. We wait and wait. The voltage does not drop. It's constant. The resistor gets rather hot. Oh yes. But the transistor has no problem because it is fully conductive. The voltage drop is less than 200 millivolt. So even a current of 1 amp, we have 300 milliamps I'm reading. So it's only some 100 milliwatt, which is okay for this transistor. Obviously, no problem. Well, I think this check was successful. I think we have located the problem, that the transistor was a bad one, bad guy. Now we can bring back this unit, this small module, into the transceiver. The TRX board is in place again on this control board. We see it here, the smaller one. Here on the rear side we can see that we have lost some pins where the vias were taken out with the TRX board, but it's not a problem because there are no wires connected. All wires which are needed are now soldered properly, so I think there's no problem. I will check it with the ohm meter, but I'm sure it's okay now. And then we can insert this board into the whole transceiver and reconnect all cables. The board is in. The cables, flat cables are also connected, all plugs are connected. Now we can flip back the front panel, fix it, and do a first test. The transceiver is switched on, the calibrator is switched also on. We see we have no S-meter deflection as it should be. The sub-receiver is switched off in the moment. When we go down to the calibrator, you see we have clear reception. And when we switch on the sub-receiver, okay, forgotten to, that's the volume. Sub-receiver also works, and main receiver works also well. What does this mean? Nothing. It was an intermittent fault. So we have to do now a long time test, a long time check, not over some minutes or so. We have to check whether the fault is really cleared and really repaired or not. Because such a intermittent fault can take some hours to come back. As we have seen during the first tests, we had a drop out, then it came back, another drop out. So I have to wait, but I have an idea what I can do. I will use a special function of my signal tracer I have. You see it on my workbench. My signal tracer has a special function, a test function, and I will show you what I mean. This signal tracer has a special function. It's a so-called test function. At the moment test is not switched on, test is switched off, so the signal tracer is a signal tracer, as we know. It's connected to the phone's output via this adapter to the input. Observe this meter here. When I increase the volume, we can hear it, and it is indicated. I hope you can see it on the... One moment, I make it a little bit better. Now you can see it. More volume shifted to the right. And when I tune to the calibrator, we see the volume, which I can control with the AF pot as we expected. No volume. And now we have the test function. This is a test whether the signal appears or disappears. We have here an index. As long as the signal is in this range, I will take out the calibrator, I will reduce the noise. And when I go to test, we hear nothing, as long as the pointer is in this range. And when the signal drops or disappears, the signal tracer generates an alarm. There's a 1 kHz signal generator inside. It's also the output here, and it is used to make an alarm when the signal disappears. And when the signal comes back, the sound disappears. It's a watchdog. A watchdog which says signal is there or signal is not there. And the lost signal generates an alarm. That's very useful to test intermittent faults. And we can observe now for many hours the transceiver. I only have to watch the tone. I have to leave my door open into my basement. But the sound is rather strong. So we can listen to it, and I can hear it in a part of my house. But I think noise, static noise is not a good signal, so I will use the calibrator. With a low tone. And now switch on the test again. And when the calibrator disappears, or the receiver gets deaf, we have alarm. And here we have no alarm. And now I will leave it for at least 1 or 2 hours and see what happens. By the way, I can simulate the fault we had also with the RF gain. Watch the S meter. This is a little bit more close to the problem we had when I reduce the RF gain. The S meter deflection increases. And the alarm appears. That's what we had when we had the fault. The S meter was completely on the right side, which was caused by the wrong AGC voltage, you remember? So this was the problem. So I leave it with full RF gain and wait. The transceiver is ready. The problem was indeed only this small little transistor on the TRX board, and this little transistor blocked this beast. It's an irony, but it's reality. That's the end of the project with the Kenwood TS950S digital. Stay healthy, stay tuned. See you on this channel.